In this video, we're going to look at some techniques for using your calculator to do function evaluation and also solving equations that arise from functions. And I have a problem here that I've already set up. I've already got this data in my calculator. I've already figured out the best fit quadratic model function, and it's already in my calculator, and you'll need to watch the videos on regression in order to understand how that happened. What I'm interested in concentrating on is answering these questions here at the bottom. And they come in two flavors. The first three are all similar in that I'm being given an input value, a year, and I'm being asked to find an output value. This process of going from an input to an output is referred to as evaluation, evaluating the function c of y here. This one below is a little different because I'm being given an output, a cost, and I'm being asked to find a corresponding input. And in this question, we're going to have to create an equation from the function, and then we're going to have to use solution techniques. And the solution techniques that we're going to use are all going to be calculator-based. So nothing by hand here in this video. Okay, so here's my best fit quadratic function to the data. It looks a little ugly because it's got lots of decimal places, but it's indeed this guy right here. And I've got it there, like I said, by using the techniques, calculator techniques that are described in the regression videos. So what I'm interested in doing is getting out of here and back to the home screen and evaluating that function, which happens to be in y1. So I'm going to hit the vars key and the y vars. I'm going to go over to y vars. Then I'm going to press enter to function, and I'm going to press enter to the function y1. And now it's out on my home screen. And I'm going to create functional notation. So I'm going to say of, and then whatever it is that I'm trying to evaluate. In this case, mid-2000 would be, well, 90 is 0, so that's 10.5. So I put 10.5 in as my input, and out comes 48.94, the answer I already have written down. How about the rest of these? Well, very easy at this point. What can I do? I can do second entry, second enter, brings up the last one, and I can simply edit it. So if I want to do 2004, that would be 14. And I can press enter, and I get 7371, my answer here on the page, and then finally 2010. But even though I can do this, I should be a little suspect because you see 2010 is getting way away from the data. This is called extrapolation, and many times if you extrapolate too far, it doesn't really mean anything. Your prediction is not valid. So even though we can calculate it, and we will, this number that it's going to generate may not mean anything. So here I go again. Second enter, second entry. See how it says entry right there? And now I'm going to put in 2010, which would be 20 years since 1990. And there's my last answer, 14,920, which I suspect is not even a reasonable or valid number for this model. Okay, so what else could I do? If I use the table set command and set the independent variable, so I went second table set, and I'm went down to the independent variable and go over to ask, and then if I do second table, as long as my function is set to graph, it'll appear here in one of these columns. And now I can simply enter in whatever values I want. So, for example, 10.5. Okay. And I could also put in 20, that other value. And what was the other one? 14. So if you got a lot to do, this might be easier than the Y out on the home screen. Those values came up really quickly. Okay, so what you've seen is evaluation is fairly easy to do in the calculator, very easy to do. So now we're down to talking about how to do things backwards, how to go to an input from an output. The first thing to do is to think about letting the function right here equal the output that you're considering. So here I am with the 8,000, and what I'm thinking of in my mind is doing this. Okay? So let's start with this solution technique I'm going to show you, which is I'm going to put 8,000 in as a function, a constant function, but a function nonetheless, and I'm going to put it in y2. Okay, and I'm going to try to graph this thing. I've already zoomed in on the data because I did zoom stat, so I'll graph it right now. And I know that 8,000 is up here because I'm making a prediction beyond the data. You know, you see I'm here at 8,000, so I know it's up there. And I know this window really isn't showing me the thing. In fact, the upper part of the window is at 7,000, so I need to make this at least, what, 8,500? All right, so once I got the window reset, I can graph this again. Here's the data, there's my best fit model, and there's my 8,000. And what I'm after is I'm trying to find an intersection point. Well, you see I can't quite see it yet because why? Well, I didn't increase the input window. So I was only looking out at 2003, and I'm going to need to look much further out than that. So how about 17 or something? That would be 2007. Let's graph that. Okay, now I think we're going to win. We're going to get a window in which I can see the intersection. So it turns out this intersection right here is the solution to this equation right here, and the solution to this equation is the answer to this problem. It's as simple as that. They're all related. The intersection is related to the solution to this equation, is related to the answer to this problem. Okay, so the calculator has an easy technique for doing that. It's called intersect. So I did second calc, and then I went down to intersect. And intersect asks you for three things. The first curve, the cursor's already on the first curve. You can see it blinking right there. You see it blinking. This is really easy when you only have two curves. And remember, a straight line is actually a curve, so don't get confused. Curves aren't curves on the road. Okay? So when you have just two curves, this is really just an enter, enter, enter process. Enter for the first curve, enter for the second up on the line, the horizontal line, and enter for a guess. And the guess does not have to be anywhere particularly close to that, just in the vicinity. It's smart enough to go right on it. And so it determined that at an output of 8,000, the input was 14.66, which it turns out if I multiply 0.66 times 12, I get about 8, and that's the 8th month of the year, so it ends up being August of 2004. Ends up being when we predict the cost will reach $8,000.